Welcome to the video session 44 of network security. So in this video we are going to study about the cryptographic algorithm SHA 512. So here actually we need to recap cryptographic hash functions, types of hash algorithm. So learning objective of this video is the main objective of this session is to get familiar with the structure of SHA 512 hash function and understanding the working of SHA 512 algorithm, able to differentiate MD hash algorithm and SHA algorithm. Prerequisite for this session is detailed knowledge on cryptography, usage of hash function. Now let's see the introduction of SHA 512. Hashing algorithms are used in many things such as network security, information security, internet security, digital certificates. Hashing algorithms play such a vital role in digital security and cryptography. SHA 512 is a hashing algorithm that performs a hashing function on some data given to it. SHA 512 is the version of SHA with a 512-bit message digest. This version, like the others in the SHA family of algorithms, is based on the Merkle damaged scheme. Now you see the figure which shows that SHA 512 creates a digest of 512 bits from multiple block message. Each block is 1024 bits length as shown in the following figure. The digest is initialized to a predetermined value of 512 bits. The algorithm mixes this initial value with block of message to create the first intermediate message digest of 512 bits. The digest is then mixed with the second message block to create a second intermediate digest. Finally, n-1th digest is mixed with the nth block to create the nth digest. When the last block is processed, resulting digest is the hash code for the entire message. Message preparation. SHA 512 creates a 512-bit message digest out of the message less than 2 to the power of 128. SHA 512 insists that the length of the original message be less than 2 to the power of 128 bit. And message preparation, SHA 512 insists that the length of the original message be less than 2 to the power of 128 bits, and SHA 512 creates a 512-bit message digest out of the message less than 2 to the power of 128. The entire message has basically three parts: the original message, padding bits of size of the original message, and this should be all have a combined size of a whole multiple of 1024 bits. This is because the augmented message will be processed as blocks of 1024 bits each, so each block should have 1024 bits to work with. The following figure shows that the original message will be length of less than 2 to the power of 128, and padding will also a variable which is the length of less than 2 to the power of 128, and also the length of the original message is also in the same to 128 and multiples of 1024 bits. Appending padding bits and representation bits L are the length. The message block and the digest as a words of 64 bits each and 16 words of totally 1024 bits. And word expansion is like this. So padding bits is the input message is taken and some padding bits are appended to it in order to get it to the desired length. The bits that are used for padding are simply 0 bits with a leading of 1, 0, 0. Also, according to the algorithm, padding needs to be done even if it is by 1 bit, so a single padding bit would only be a 1. The total size should be equal to 128 bit short of a multiple of 1024, since the goal is to have the formatted message size as a multiples of 1024 bits, that is n into 1024. After the size of the original message given to the algorithm is appended, the size value needs to be represented in 128 bits and is the only reason that the SHA 512 has a limitation for its input values. Since the size of the original message needs to be represented in 128 bits and the largest number that can be represented using 128 bit is 2 to the power of 128 minus 1, the message size can be at most 2 to the power of 128 minus 1 bits. That message, how it is going to be processing? The message processing is done upon the formatted input by taking the one block of 1024 bits at a time. The actual processing takes place by using two things, the 1024 bit block and the result from the previous processing. The part of the SHA-512 algorithm consists of several rounds and an addition operation, so the message block 1024 bits is expanded out into words using the message sequencer, 80 words to be precise, each of them having a size of 64 bits. So minority function is AJ and BJ, which XOR of BJ and CJ and XOR of CJ and AJ. Conditional function is EJ and FJ XOR of not EJ and A and GJ. Rotate function is rotate of A equal to rotate of R28 of A XOR of rotate of R34 of A and rotate of R29 of A. And reference books as Ferzon and Whiteman and also William Stellings. So in this we can expect the multiple question or choice question is SHA means a secured hash function, simple hash function, standard hash function algorithm, and none of that is a secured hash algorithm. So number of rounds in each compression operation is 80 and SHA-512 produces 128-bit or 512-bit hash code. SHA algorithm is based on the Merkle-Damage scheme, that is true. Input message block size SHA-512 is always 512 bits. Thank you.